Okay, so now we're going to do the naive Bayes classifier using SAS Enterprise Minor, and let us use the same project from last time, MGT4270 classifiers. Okay, so we have one diagram here already. Okay, and okay, let's create a new diagram, and we'll call it N chapter 08-NB, NB for naive Bayes. Now we're going to bring in flight delays. Okay, so we're going to now create a new data source. And okay, hopefully you've copied the flight delays data set into C:MGT4270, which is right there. Okay. Now we have to set up the metadata. Okay. Once again, so we looked at, if you want to do advanced metadata information, then you can set the thresholds differently. So missing percentage 50 means if your predictor variable has 50% missing values, then that predictor will be rejected. So reject variable with excessive missing value. So the first two go together. Class level count threshold is 20. So if you have given an interval variable that has only 20 distinct values, then it will be classified as nominal value. And if you have an ordinal variable with more than 20 distinct values, then that will become interval variable. So detect class levels is yes, that these two go together. So reject level, actually the three of them. So if you reach the threshold, then that variable will be rejected. So reject variable with excessive class value. So you can change all of this. Okay. So we'll just accept the default. Okay. So now let's review. We have nominal, and the CRS departure time should be rejected. Okay, because we're not going to use that. Day of the month is interval, that should be because there are 30 of them, so we'll change that to nominal. Okay, day of the week is nominal. Departure time, so this needs to be binned, so we'll get to that in just a second. Destination is nominal. Distance is, I don't know why it's nominal, because maybe it has less than 20 distinct values, because there are only 3 origin airports and 3 destination airports. There are not a whole lot of values, but we're going to reject distance because distance is not a predictive factor. And flight date is also to be rejected, because date doesn't matter. It is the day of the week or day of the month which is important. Flight number is to be rejected as well. If you want to include distance, we can do that, but I'm going to reject it. Flight status, that's our target. Now there is one problem here that we will come back to in just a second. Origin is input and weather is input. Okay. Now the target, okay, what the target, the event of interest, okay, so there are only two possible values, right? Delayed or on time. Okay. Now, we want the target of interest is delayed. Right? You want to detect delayed, the flights that will get delayed. That is your target of interest. So you want to make sure that that is so. So here you need to change it to ascending. What this does is it forces one particular value to be chosen as the event of interest. Okay, because there are two possible values. Otherwise, your output, the report, if you don't use ascending, okay, let's do that. Okay, let's just keep it as nothing. Okay, let's see what happens, and then we'll come back and correct that. Okay. All right. So now we'll finish this up. So I'm going to now use the straightforward approach, quick, and then we will look at other ways of doing the same thing. Okay, so let's bring in flight delays data, okay, and say we want to partition 60-40, for example. Okay. And the naive Bayes is in HPDM tab. HP stands for high performance, DM stands for data mining. So high performance data mining, so there are some of the same methodologies in the regular or repeated here. Okay, and the naive Bayes classifier is available only under the high performance tab. So bring that in, connect it up. Okay. So now you see here, let's check the variables. Okay. So all of that. Okay. So that's good. Now there are four possible choices that we have. Okay. Naive Bayes is the first one. That's what you need to choose. The TAN and BAN and Bayesian network, they use more advanced, complex methodologies. Okay, so we are not going to get into that. So we'll select naive Bayes. Okay. Now, so here is our number of bins. Okay. So it specifies the number of bins for interval variable. So if you select that, then okay, you can change the number of bins here if you want. So what this will do is it will take any interval variable that you have as an input, it will automatically bin it for you. Okay, so you don't have to bin interval variables yourself. Okay. But sometimes you may want to. Okay, if that is so, then how do we do that? We've already done it once before, I think, in transform. So we need to use a transform node, and then we can do that. All right. So let's go ahead and run it. Okay, let's look at the results first. Okay, output. Okay, see here the order is descending. So that means the event of interest is assumed as on time. So we have on time and delayed. So if you do not explicitly state that you want the values to be in ascending order, it's like 0 and 1. Now 1 being, okay, typically you will have 0 or 1 for your binary target, and you would want the second value 1 to be the event of interest. So you want it to be descending, which means that you don't have to do anything. So the first value is used as the event of interest. But if you want 0 to be the event of interest, then you have to specify ascending. So that's what we did here in target. So here, if we use edit variables, I right click and edit variables. So flight status, okay, you want to make it ascending, so which means delayed will be the first. Delayed will be ahead of on time, and delayed will be the one. Let's see what happened here. Ascending, okay, so now it will work. Okay, now let's look at ascending. So ascending is the order, and delayed is the event that is taken as the event of interest. Okay, so the output is now for delayed, where you have the classification table right here.